Hello Huskies, welcome to the first video of the year in Unit 1. This is going to help you out with the classwork and the homework of Symbols at School, Unit 1, Day 2. Now before I start, I just want to point out that you are welcome at any time to fast forward through this. If you feel like you understand and you don't need any help with the classwork, my usual routine when I do videos is I will explain every question on the classwork, but I will not do every homework question. Unless it's the unit review, then I will work out every question because I expect you to try and do some of these on your own. And if you didn't understand how to do the homework, the best thing to do is to practice on the classwork as I work it out with you, and then you try your independent practice on the homework. Okay. Our objective for the day, I can use variables to write mathematical expressions and determine their meaning. So we are going to try and figure out how to be efficient using math and how to figure out what stuff means. So the very first page of your classwork, you have this giant table. I have two of my sons have worked in the past as custodians at a school, and just hearing them talk about all the stuff they have to keep track of, you know, I think if they had to remember so-and-so's classroom has 38 desks and the next classroom has 42 desks, but there are 3 teacher desks because they're shared, they would just get really overwhelming very quickly. And so an efficient thing to do might just be to use some variables, and they could change depending on which classroom you're talking about, or how many classrooms you're talking about. So that's kind of the premise behind this whole thing, is we're just going to use some variables to represent stuff that's all around us at school. So the first question says, write an expression for the total number of desks in a classroom. Well, first you might think, well, duh, there's, 39 desks. Well, that's true. There are some 39 student desks in my classroom, but I also have a teacher desk. And so all total, there would be 40 desks in my classroom, but we don't want to just say 40 because we want this expression to apply to any classroom. What if it was maybe the band room? How many desks are there in the band room? There aren't any student desks in the band room, maybe just the teacher desk. How many desks are there in the classroom across the hall? They had 2 teacher desks because 2 teachers were sharing that room. So it's going to be different in every classroom. So we can see that the number of student desks in a classroom is represented by this big D with a little s, and that stands for desks, and then the little s just gives us some more information. That's an s, not a 5, that those are the student desks, because they're all desks, but these ones are student desks. So what do you think the teacher desk would be? That would be the number of desks that teachers use. And so the total number of desks in a classroom is going to be the number of student desks plus the number of teacher desks. Now it looks more like a 5. And that's it. That's all you have to do. That expression will work in every classroom in the school. We could use that to represent how many desks are in the room. Sometimes the student desks will be 0. Sometimes the teacher desks will be 0. Sometimes, like in the auditorium, there are no desks at all. So yeah, it's going to be different, but that expression will work in every classroom. Okay, now for number 2, you're supposed to write an expression for the total cost to replace all of the lights in the classroom. Maybe not lights, but when my son was a custodian, he broke some of the covers on the lights. Every day he would come home and he'd say, oh, I broke another light cover. And I kept thinking, well, how much is it going to cost to replace all these light covers? Well, that would be the cost of one light cover and multiplied by how many of those that he broke, right? Okay, well, same thing with the lights. Sometimes you can put numbers in to help this make more sense to you. Maybe we have, I don't know, 60 light bulbs in my classroom, but if each light bulb cost $2.50, how much would it cost to replace all the light bulbs? Okay, well, you would take the number of lights, that's going to be L, and you would have to multiply that by the cost of each light bulb. The cost of each light bulb. Now remember, like let's say that you broke 4 4 lights. Then you'd have to multiply 4 times the cost of each light bulb, which would be like $2.50 or whatever. Maybe another custodian is even more careless and they broke, I don't know, 11 lights. Then that's how much it would cost. Maybe somebody's not very careless and they only broke 2 lights. But maybe the cost of the light bulbs went up one year, and so now they cost $3.50. So you can see that this pattern is still the same. How many lights you need multiplied by the cost of each light bulb. Okay, number 3, write an expression if 13 student desks need to be replaced in the classroom. And so we're going to find, well, we know there's going to be 13 this time. Number 2, we used a variable to represent how many, but this time we know how many. It's 13. How much does it cost for one desk to be replaced? Well, that is CD, the cost of a student desk, right there. So I need 13 of those, and that's going to be 13 multiplied by CD. You'll notice I'm using a dot here for multiplication, not an X like that, because an X usually stands for a variable now that we're in higher math. Back in elementary school, when you didn't use any variables, an X was okay, but we really need to move to a dot, or you could use parentheses around it like that, and that tells you to multiply also. Okay, let's see if we can go a little faster. Write an expression for the number of student desks per row. Well, how many student desks are there in a classroom altogether? We already said that was DS. So imagine then we have this classroom and it's made up of these rows of student desks, and each, there's so many desks per row, and that's what we're trying to find out. How many desks per row? Well, what would we need to know? How many rows there are. How many rows of desks there would be in a classroom, and we happen to have a variable for that. That would be R. So if I had 40 student desks and I had 5 rows, then how would I figure out how many desks are in each row? I would divide, right? 40 total desks divided by 5 rows would be 8 desks in each row. Okay, so maybe I don't know how many desks I have, but I just represented it as a variable. And I don't know how many rows I have, but I can represent that as a variable. I'm still going to divide them, and that would tell me how many desks per row. So sometimes it helps to do a concrete, less abstract version of this using numbers, and then we can translate that into the variables and have it make sense to us. But the answer is just this expression using the variables. Okay, next one. Write an expression for how many more light bulbs there are than teacher desks. I don't know why you would ever want to figure that out, but how many light bulbs do we have? That's L. And how many teacher desks do we have? That was DT. We're going to subtract them because that's how you find how many more of something there is. You would take the number of light bulbs and subtract off how many teacher desks, and that would be how many more there were. Okay, last one on the front. Write an expression to represent the cost of 7 pens. Well, how much is 1 pen? That's right here, CP. So 1 pen is the cost of a pen. That's why it's CP. But I need 7. So I could say like this. The cost of 1 pen plus the cost of another pen plus the cost of another pen. Let's see, 1, 2, 3, 4, 5, 6, 7. That works. Does that represent the cost of 7 pens? Absolutely. Man, I wish there was some kind of shortcut for adding the same thing over and over and over again, because that's really boring and tedious. Oh, wait, there is. And it's called multiplication. So instead of adding up the cost of 7 pens, we could just multiply that by 7. And that would also tell us the cost of 7 pens. Okay. Now, on the back, you're going to do the opposite direction. You have to tell me what these expressions mean. And I need you to be very specific. And also, I need you to interpret what it means. Don't just translate. Because sometimes when you just straight up translate like a robot, you don't really pay attention to the meaning. And sometimes it doesn't mean anything. Some of these expressions don't mean anything. In fact, 3 of them have no meaning at all. Okay, so be careful. Don't just translate without thinking. You're not a robot. You can think. Okay, so number 7. We've got a big P and a little p. If you go back over here, capital P was the number of pens and small p was the number of pencils. So if I just straight up translated this, it would be the number of pens plus the number of pencils. But that is not good enough. I don't want you to just straight up translate like that. I want you to use some specific words and interpret what it means. Number of pens plus number of pencils. Well, to me, that kind of sounds like the total number of writing utensils. Right? That's, all the pens in the room plus all the pencils in the room. That's everything I have to write with. That's what that means. Can I add those two things together? Sure, I can add the number of pens plus the number of pencils. It's just how many things I have to write with. Okay, so then on number 8, why would I multiply those together? The number of pens multiplied by the number of pencils. Multiplication usually represents like groups of something. If I have so many pencils, why would I say I have that many groups of pen like that? No, it doesn't mean anything. So, yeah, you could straight up translate that to say the number of pens multiplied by the number of pencils, but what would that be? That doesn't even mean anything. So, no, don't just straight up translate it, interpret it. Okay, now W stands for, I can't remember, the number of whiteboards. So you can think about in my classroom, I have some big whiteboards, and I had some smaller ones that I glued on the wall also. So W is the number of whiteboards. And CW is the cost of each whiteboard. So, wait, what would it mean to add up how many whiteboards I have plus how much they cost? Like, what unit would that even represent? If this is how many, and this is a dollar sign, I couldn't add those together. It wouldn't mean anything. Okay? Now, I understand that this is confusing for a lot of people. You're like, wait, no, that does have a meaning. It means the number of whiteboards plus the cost of each whiteboard. Yeah, that's just if you translate it. That doesn't really mean anything. Let's say that there are 7 whiteboards in my room, and the average cost of each whiteboard is $500. Does that mean 507 whiteboards? Does it mean $507? Like, what? I'm speechless. It doesn't mean anything. On the other hand, if we have the number of whiteboards in my room, like maybe there are 7, and the average cost of each whiteboard is $500, then I multiply 7 times 500. Wouldn't that tell me something? I would, okay, if I had 1 whiteboard, it'd be $500, 2 whiteboards would be $1,000, 3 whiteboards would be $1,500 it's the total cost of all the whiteboards. Now, notice again the words I'm using here. I've got this word total, and I'm not just translating it. Can't write. Total cost of all the whiteboards. I'm interpreting it. What does it mean? Okay, number 11. W is the number of whiteboards, and L is the number of lights. And why would I add those up and divide them by 2? That sounds like finding the average. The average number of what unit would I use there? The number of whiteboards plus the number of lights. So if I add those together, that would be what? The number of light whiteboards? No, that doesn't have any meaning. So see, a good technique here is to ask yourself, what unit would it be? What am I finding here? What unit would I use? I don't know. Doesn't have a meaning. Okay, and then this one should sound kind of familiar. If I have the total number of student desks, and I divide by how many rows there are, that's going to give me the number of student desks in one row. And in fact, it's exactly like what we did on number 4 in the front, just going the opposite direction. So it's the number of student desks in one row. Okay, if you have a really firm understanding, you could probably do the rest of these on your own. But if not, that's okay. I'm going to kind of just buzz through these really quickly. It's sort of a different situation. We're talking about a movie theater that only shows 1 movie per day, and they only sell 1 size of drink and 1 size of popcorn. So not a lot of variety at this movie theater. But we can have some symbols to represent each topic. So I'm going to say that the children at the movie theater, The number of children at the movie theater. I'm going to call this K, actually. I'm going to reserve C for something else. If you want to call it C, that's fine. I'm going to say that the number of, I should have written, the number of children at the movie theater is K for me. And then the cost for an adult movie ticket, I'm going to call that C for cost and A for an adult movie ticket. That's how much it costs for one adult to go to the movie. Now, how many popcorn containers were sold? I'm going to call that P. How many adults? The number of adults at the movie theater. I'm going to just call that A for the number of adults. And the number of drink cups sold. I don't know, D for drinks. The cost for a child movie ticket, that's cost again. So I'm going to call that C, and I'm going to call it K for kids, because C to me stands for cost. So the cost of a kid ticket. The cost of a popcorn container could be C of P. And the cost to buy a drink could be CD, the cost of a drink. Okay, so then 13 says, write an expression for the total number of people at the movie theater. Well, that's the number of children, which we said was K, plus the number of adults, which we said was A. That's how many people are there, all total, kids plus adults. Okay, 14. Write an expression for the total amount of money that the theater collects on drinks per day. What if only one person bought a drink? How much money would they make? Well, they would have collected the cost of one drink. What if 2 people bought a drink? Then it would have been 2 times that. Or 3 people bought a drink, it'd be 3 times that. Or 13 people bought a drink, it'd be 13 times that. So you kind of get my idea. Well, we don't know how many people bought a drink, do we? Yes, we do. It's the number of drink cups sold times however many, the cost of each one. And so that's actually, our expression is the number of drinks times the cost of each drink. Okay, now 15 is kind of fun. You can just write something that doesn't make sense and explain why it has no meaning. Like, for example, I'm going to say maybe P plus CK. Why would I add how many popcorn containers were sold to the cost of one child ticket? What would that be? Would my units be money? Would my units be popcorn? I don't know. It doesn't mean anything, so that's why it has no meaning. I did my explanation verbally, but you can write yours down. Okay. Now, the next thing is going to help you out on the homework, I hope, and it's a review of stuff you've done hopefully in 7th and 8th grade. So imagine you're going on a road trip with your family. I used to do this all the time with my dad. Well, when are we going to be there? But thankfully my dad didn't get angry with me. He gave me math to figure out. And he would say, well, it's 600 miles away and we are going 70 miles an hour. So figure out how long it's going to take us. And he would have me do mental math, and that's how he kept me from whining in the car. So, how far would you travel? How long would it take? How fast is the car going to be going? So this distance scenario is something that you encounter every day in your life. Hopefully you understand how to find the miles per gallon when you start driving, so you know if your car is getting good gas mileage or not. Miles per gallon, that sounds like a fraction, like you would divide the number of miles you drove by how many gallons it took. Okay, well, this distance thing is related to that. How far you're going to travel depends on how long you go and how fast you go. So if I was going 70 miles an hour and I did that for 1 hour, I would go 70 miles. If I was going to go 70 miles an hour for 2 hours, I would end up going 140 miles. If I went 70 miles an hour for 3 hours, I would go 210 miles. Well, what's going on here? This is my rate. This is how fast I'm going, my speed. This is the time that I'm driving in hours because I'm driving in miles per hour. And this ends up being the distance over here. The total distance that I have gone depends on how fast I was driving and how many hours I spend in the car. So if D is distance, T is time, and R is the speed or the rate of the car, then an equation that you can write that relates all those together is what I lovingly call DIRT. Distance equals rate times time. DIRT. That equation right there is so basic. It's going to serve you for all kinds of stuff through your life. It could be if you are swimming, if you're in an airplane, if you're in a boat, if you're in a car, any kind of linear distance like that, you're going to use the DIRT equation. Distance equals rate times time. So that's your equation. That's all you need to do your homework. Now let's start the homework. Again, I'm not going to work out every single question. I'm going to just hopefully give you enough hints that you can be successful on your own. So we have another table. This is about triathlons because I love to run triathlons. And so in a triathlon, you first swim, and then you get out and ride your bike, and then you run. And whoever can do that, all three things the fastest, wins the race. Okay, so number 1 says, write an expression using the symbols above to represent the distance someone runs in a triathlon. Well, we just talked about distance. Distance is the rate times the time. So up here in my table, I don't have any kind of letters that stand for distance, but I know that the total distance I'm going to run will depend on how fast I run, which is VR, and how long I run, which is R. R is the minutes I spend running. V here stands for velocity, which is a word that you're going to run into a lot in physics in 10th grade. So hey, you might as well get used to it now. Velocity, speed, rate, those are all kind of the same thing. Okay, so the distance that I'm going to run is going to depend on how fast I run, that's my velocity, multiplied by how long I run. And that is my distance running. I could use a little dr here if I wanted to, but really what I'm interested in is this expression. It's VR times R. That's the total time that I spent times the total time I spent running multiplied by my speed running. How far did I go on my bike? Well, it's the same thing. It's going to be the speed I was on my bike times the minutes I spent on my bike. That's how far I go on my bike. So then for number 3, when you have to write an expression that represents the total distance of a triathlon, well, I need the distance that I ran plus the distance that I biked plus the distance that I swim. So you're going to have to come up with a swimming expression and then write them all added together. There's no simplifying to do. It's just going to be, like I'll start it off, it's going to be VR times R plus VB times B plus the swimming distance. Then I'll let you finish that. Okay, number 4 says write an expression without using B to represent the number of minutes on the bike. Well, that seems silly because B represents the number of minutes I spent on the bike. In fact, I know that the distance I spend on the bike is going to be B times VB, like that. So that's one thing I could do that's talking about it, but I also have this other. Let's think of something else. How long did I spend on the whole race? Oh, well, T. That was the whole total that I spent on the race. And the total time that I spent on the race was how long I spent swimming, plus how long I spent biking, plus how long I spent running. Right? Doesn't that make sense? That's the triathlon. You swim, you bike, you run. That's the total. Well, I want an expression without using B. So what I could do here is I could move these over and say that the total number of minutes I spend minus the time I spent swimming minus the time I spent running, that would equal how long it took me on the bike, right? If I told you, well, it took me an hour and a half to run this triathlon, and it only took me 30 minutes to swim, and it only took me 30 minutes to run, well, how much time is left? That's how much time it was on the bike. That's exactly what I'm saying right here. The total number of minutes, take off the swimming time, take off the running time, and that is how much time I spent biking. So my expression, without using B, is going to look like that. Could I have also said T minus R minus S? Yeah, if I took my total time and I subtracted off the running and then the swimming, that's the same as subtracting off the swimming and then the running, isn't it? Okay, there are some review questions. Oh, well, sorry, we're not there yet. First of all, what does it mean to multiply SBR, the number of minutes swimming times the number of minutes biking times the number of minutes running. What? What does that mean if I multiply the time together? It doesn't mean anything. Multiplying time together, that has no meaning. So again, some of these don't mean anything because why would I multiply the times together? But then if you jump down to number 7, oh, does it mean something to add all those up? Yeah, that's going to be my total time spent in the race. So again, don't just write time swimming plus time biking plus time running. No, it means that's the total time that the triathlon took me. So again, interpret them. Give me specific things. Use words like total or things like that. If it doesn't mean anything, tell me why. Now we're on to the review on the back. Okay, hopefully everybody remembers how to evaluate. Evaluate is when I tell you that a letter means something else, and so instead of A, I'm going to replace an A with a -3, and instead of B, I'm going to replace that with a 2. So I'm going to get 2 times -3 plus 3 times 2. Hey, that's -6 plus 6, and that ends up being 0. Cool. Okay, so then number 17 is just a story problem that's like that. Here I give you an equation. I tell you C is the cost and R is the number of remotes. And the question says, what is the cost? I don't know. I'm trying to find that. So guess what? I'm not going to plug in anything for C. But I do want to find out the cost of producing 1,000 remote controls. Well, R is the number of remotes, which was 1,000. So you're going to replace R with 1,000. And that's all I'm going to do for you on number 17. On number 20, it's just asking, just asking you to simplify. And this is a review of the distributive property that you learned in 7th grade. So when you multiply that, you're going to get -3 times x, which is -3x, and -3 times -6, which is a +18. Don't forget to distribute the negatives as well, all the way through there, so that you can get the correct sign after you distribute. That's a tricky thing. Okay, number 21. This is just taking you throwback to elementary school, add these two fractions together. I'm just trying to have you remember that before you can add fractions together, they need to have a lowest common denominator. So the lowest common denominator of 3 and 5 is 15. But then you can't just write a 2 on the top of the 15. You have to say, well, 3 times what was 15? Oh, 3 times 5. So 2 times 5 is 10. Remember when we did that? And I'm going to let you finish that. That's all the hint that I'm going to give you for 21. 22, I'm asking you to simplify this. And you're going to have to combine some like terms. But first, you better distribute and take care of that. So this is actually 2x plus 2. And then you're going to look for like terms. So you're going to have 4x and 2x. And if I add all those up, that gives me 7x. And then I'm going to combine the constants. Now, notice how I'm circling the sign in front. Remember that negative stays with the 16. That's a -16. Plus 11 plus 2. So that is -16 plus 11 plus 2 is -3. So that entire thing simplifies to be 7x minus 3. 23 is just another review, and I'm trying to see if you know how to do this simplification thing where you're saying 3 goes into 3 once and into 9 3 times. And then you can multiply straight across on these fractions, so you get 12 over 1. What about that x? Yeah, it's still there. So that whole thing just simplifies to being 12x. That's a skill you're going to need for next time's homework. All right, that was kind of a long video. Usually they don't take 30 minutes, but I wanted to give you a really good, strong foundation for the rest of this unit. Good luck on the rest of your homework.